Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be dealing with the ideal gas law equation. So let's get into this. So in my previous videos I talked about the relationships between different properties of gases, the volume, the amount of gas, the temperature, and the pressure. And so in this video I'm going to put it all together and show you how we got this law or this equation called the ideal gas law equation. So if you remember from my other videos, I showed you that pressure is proportional to the amount of gas if temperature and volume are constant. And this gave us the kind of relationship that pressure over N is equal to some constant K, pressure over the amount of gas. And that comes from the proportionality here. And then we saw that pressure is also directly proportional to temperature. And so that's only if the amount of gas and the volume are held constant. And we saw that that led to P being over T being equal to some constant. I didn't tell you what the constant was, but some constant. And that gave us another gas law. And then we saw that pressure is proportional to the 1 over volume, or the inverse of volume. So pressure and volume are inversely related to each other if the amount of gas and the temperature are held constant. And we saw that that gave us pressure times volume is equal to some constant. And that gave us our P1 V1 equals P2 V2, Boyle's law. Right? So each of these gave us an equation that we could use to solve a problem. Now we can put this all together. So if I take these three and put them together, then I get pressure is directly proportional to both the amount of gas and the temperature, but inversely proportional to the volume. Now, I can create this, or I can change this into an equality by adding a constant. So just like before, if I divide both sides by temperature, right? So I'm going to divide both sides by temperature. So temperature cancels out. And then I'm going to divide both sides by the amount of gas. So the amount of gas cancels out. And now I'm going to multiply by the volume, both sides by the volume, and the volume cancels out here. So it's proportional to 1, right? All of this cancels out. It's proportional to 1, right? But we can then rewrite this as Vp over Tn, and that would be equal to some constant K. So basically, what I did here is I just added these three together and I got this. So this here is related to a constant K, but we have a name for this constant. This is actually the ideal gas law constant, which is what we're going to call R. So it's given the symbol capital R, and this is the ideal gas law constant, or it's also referred to as the universal gas constant. Let me double check that. Universal gas constant. I know it more as the ideal gas law constant, but either one of these is useful. Okay, so then what I get here is, if I write over here, Vp over Tn is equal to R. And then if I rearrange this, if I multiply both sides by Tn, and this cancels out, I get the famous version of this, which is PV equals nRT, or PIV NERT, if that's what you want to call Pivnert. So this, ladies and gentlemen, is the ideal gas law constant. And so you can use this to solve problems. Now, before I get into the idea of solving problems, let me talk about the R constant. There are a couple of values that you can use for R. So R can be equal to 0.028, 0.08258, and the units would be liter atmospheres over Kelvin mole. Or the value could be R equals, let me double check, yes, 8.3145. And here it would be liter, let me double check, liter, yes, liter kilopascals over, again, Kelvin mole. And you'll see right away the difference between this one and this one is not only the numbers, of course, the numbers are different, but why are the numbers different? If this is constant, right, shouldn't be the same numbers? Well, yeah, it should be the same numbers if you have the same units. So here you'll notice that I have liter atmospheres over Kelvin mole. Here I have liter kilopascal over Kelvin mole. So both these values here, it's the same value, but it's the same constant, but the value here is different because here I'm using atmospheres, here I'm using kilopascals. So which one you use will depend on what values or what units you are given, and those need to cancel out. So you need to make sure that you use the right value of R that has the units that are going to cancel out. So regardless of which one you use, you have to remember that if you're using this one here, then all of the other gas properties have to be in the proper unit. So if you're using this one, then your pressure should be in atmospheres because the constant has atmospheres as a unit. So if you don't use pressure, if you don't use atmospheres for pressure, then you're not going to cancel that out and you're not going to get the right answer, right? Also, make sure temperature is in Kelvin. So you'll notice that both of these have K for Kelvin. So if your temperature is not in Kelvin, it's not going to work. So you got to make sure temperature is in Kelvin. N is in moles, right? So R here is in moles. So you got to make sure that N is moles. So if you're not given moles, if you're given a mass, then you got to convert that to moles. And then finally, volume has to be in liters. So you see in both of these, you have L for liters. So volume should be in liters if you're going to use the ideal gas law to solve a problem. So with regard to pressure, it could be in atmospheres or it could be in kilopascals. So if you're going to use this one, make sure that your pressure is given in kilopascals. If you're given your pressure already in kilopascals, you might want to go with this one and make sure everything else is converted to the proper units. If you're given pressure in atmospheres, then you might want to use this one, but just again, make sure that the other properties are in the proper units. And so that's what you want to look out for. Now, as far as using this equation or when to use the equation, the thing to remember is that in order to use I shouldn't say in order, I should say the type of problem in which you are going to use the ideal gas law equation is one in which there is no change in the properties, right? It's not going to be a problem where I'm starting with one kind of pressure and I change the pressure to something else. Or if I start with a certain temperature and then the temperature changes to something else. Or if I start with a certain volume or a certain amount of gas and then that changes. It's not going to be that type of problem. That's not the type of problem that you're going to be using the ideal gas law constant or ideal gas law equation here. This equation is used when you're not given any change whatsoever. All you're given is a set of properties, right? And then you're looking for the missing one. So for example, in a problem, I give you a gas, and let's say I say the gas, I give you the pressure. So the pressure's 1.0 atmospheres. And I say, oh, the volume of this gas is 3.2 liters. And then I say that the amount of gas is 2.4 moles, right? And then I say, okay, what's the temperature of this gas, right? So nothing's changed. I didn't change the moles to anything. I didn't change the amount of liters. I didn't change the pressure. All I did was I gave you a set of conditions. I said, okay, here are the conditions for pressure, volume, and the amount of gas. And I'm asking you to find the other property. What's the other property? Temperature. So in this case, all you would do is plug in the values, and again, making sure that all the units match with whatever R value you're going to use. As long as they match, you're good to go. So once the units are converted to the proper unit, if you need to, then all you need to do is plug them in and solve for the missing part. In this case, I would solve for T. So I'm looking for temperature. So I'll plug everything else in, solve the equation for temperature, and I get my answer. And during that case, during that process, I would make sure that everything, all the units cancel out that need to cancel out. If I'm looking for temperature, then I better end up with a Kelvin unit. If I do my calculation and I cancel out the units and I don't end up with a Kelvin unit left over, then I did something wrong. I made a mistake, so I got to go check my work. So that's when you use the ideal gas law equation. If you do run into a problem that does have a change in it, like going from one pressure to a different pressure, or from a one temperature to a different temperature, if you get a problem like that, don't try to use the ideal gas law. In that kind of problem, you're going to want to use the combined gas law. And in my next video, I'm going to show you how to use the combined gas law into solving those problems. So this is the end of the video. I hope you enjoyed this video. I hope you're clear on what the ideal gas law equation is and how to use it. If this was helpful, if you enjoyed the video, then please like the video, share the video, hit that like button over there somewhere. And also make sure you subscribe to my channel, hit the notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a problem or a question you need help with, then put that down below in the comment section. I would love to do that for you. Thanks for joining me, and have a great day.